I'm going to talk about one more driver option in here, and this one is not available in all drivers. It certainly is available in the Java driver. I'm going to use an acronym when I talk about this quite a bit, and that acronym is HA. And in this context, at least, HA is going to stand for high availability. Now, high availability is actually when we discussed how to bring load balancers into the equation and how those could potentially work with MongoOS if configured correctly. This is one of the things that we were essentially talking about. That's one of the reasons people use load balancers, is to make something highly available and to make failures transparent to either the end user or the application that's attempting to consume a service or use a database. When you're constructing your Mongo client object, or you're creating the equivalent in other drivers, you've got your MongoOS deployed on your application server, you connect to that, and that talks to your sharded cluster, and you go about your business. However, there is another way to do this, and that's if you've got multiple MongoOSs deployed, you can pass in a list. Imagine the list might look like this. Host 1, port 27017, host 2, all the way up to host n, however many actual MongoOSs that you actually have here. And just to note that this is only for MongoOS processes. Anything else, you're going to have a replica set. Now, you can connect to different members in a replica set. You can only have one primary, for example. You can read from multiple secondaries, and the driver will take care of that for you. So that's a different type of availability that's built into the fact that you're using a replica set. So when we're talking about this sort of special high availability option, we're focusing on the MongoOS itself and connecting to that. Each one of these represents a MongoOS process running on different hosts across your data centers, across your network, whatever way you've actually deployed these things. Your application, your driver, will actually connect, say, to the first one, and it will use this MongoOS very happily, issuing queries, writes, updates, commands, etc. In the original case where you've just got your localhost MongoOS defined, if that localhost MongoOS crashes, or there is some other sort of problem with it and it is not responsive, that's it. You're pretty much going to get socket exceptions, connect errors, various other different errors back to your driver. In this case, if this host dies, then we just connect to the next one. Very similar to the load balancer problem, although it will connect and your client can go about its business happily thereafter. There will be some fallout. You have your client, and we'll just use the simplest case. We've got two MongoOSs here. You have a series of queries being run in S1. This goes away, and that's not a problem. You've got two in the list, so after the failover, the client just connects to the second one and continues on. However, what about queries that were in flight? I'm going to use a blue line here. What I mean by in flight, you've done your initial find. It's hit the MongoOS, it's gone out to your shards over here, and you've gotten your initial result set back. The total number of results is actually greater than can be sent back in a single batch, so you issue a get more. Some more results come back. Let's say it doesn't fit in two batches, another get more will come in, etc. etc. And this could go on until the cursor is exhausted, essentially, and all of the results have been returned. And at some point, the bad event happens. Somewhere in here, the MongoOS has a problem, dies, goes away for some reason, and your client switches over to the new MongoOS. Now, it will still issue the get more for this original cursor that only existed here. This will be sent to this new S2 MongoOS, and it won't have any idea what that cursor is. So you might get an error, something along the lines of, cursor not found. So that'll raise an exception, and you'll have to decide how to deal with that exception back here in your code. It is possible to get a nice sort of transparent failover between MongoOS processes, but always with that caveat that because the MongoOS processes are not sharing state across all of them, they're not aware of what each other's cursor's current in-flight queries are. So if that happens, you'll still have this sort of edge failure case, but any new queries can continue on and take advantage of the high availability option that you've implemented in your driver.